Good morning, students. My name is Pratik Singhal. I'm assistant professor at SIRTE from CSE department. So, as we know that nowadays the research is most important. So, today we will discuss some new, or you can say that trendy topics over IoT on the authentication messages. So, as I am discussing, the main topic is that end-to-end message authentication over IoT. Or I can say in a simple language that while we are transferring some message, is that message is end-to-end authenticate or not? End-to-end means as per the user end, as per the another user end means you can say that sender end and the receiver end is that message is authenticate over both end or not over IoT. As we know that today in the recent era, or you can say that the upcoming era, the authentication is most important, and the breaches also happened in networking. So, and or you can say that over IoT. So today we will discuss some research related to end-to-end message authentication. What are the techniques? How we can propose that? What are the proposed work? We can work over message authentication. What are the types of message authentication? So let's start.
So, what is IoT? IoT is the Internet of Things, which was firstly introduced by the Calvin Austin in 1999 in MIT labs. It is also known as the supply chain management because they are the interconnection of networks between the objects. Means you can say M2M communication. The devices has been connected or interconnected with each other over internet or via internet. So it has been connected while sharing the data exchange from physical world to virtual world. So we can access the data or information from anywhere and anytime. So it is the interlink between devices. Nowadays, there are the various sensors has been generated for communicating between one device to another device. The main device is RFID, radio frequency identification. It is the best technology where we can communicate the message or information between two devices by using the protocols. So there are the various protocols, maybe known as the POP protocol, Constraint Application Protocol, ZigBee protocol, 6LoWPAN, 6 Low Energy PAN protocol, Z-Wave, etc. IoT is various. IoT is being used in various other applications like e-health monitoring, e-transportation, e-utility, etc. Maybe you can see that there are the various application is being used in agriculture, everyday life, in vehicles, smart homes, surveillance camera, security, etc. IoT elements are the connectivity, communication, intelligence and action, and automation. Connectivity, there should be the connection between every devices in every dimensions. So it is a hyper connectedness. In communication, the devices should be communicated or start turning into communicating from one to another. Intelligence and action, the sensors or the devices is quite intelligent to transferring the data or smart uses. Automation, you will know that the smart automation, whenever any person come inside, the automatically the lights has been turned on. So this is also known as the automations by IoT. I have used the COPE Internet Constraint Protocol. Under this, there are the Internet protocols. Internet protocol stack is included the four layers. Application layer, which contains the COPE, AMQP, MQTT, XMPP protocols. They are the protocols which comes under the application layer. DTLS and UPD are the protocols comes under the transportation layer, whereas RPR and 6LoWPAN comes in the internet layers, where the IEEE 802.11 and 802.15 series has been come in the link layer constraints. So this is the internet protocol where you can see the application layer, transport layer, network layer, and data link layer, and physical layer. So you can see in the application layer, they are the COPE protocol, Constraint Application Protocol, that I am using for communicating from one device to another device in a unicast message, but with the DTLS security. So in the application layer protocols precisely, you can see that COAP uses the UDP, quality of services yes, and the architecture is request and response. Me and security is DTLS. The architecture request and response means whenever you request the data, so it always responds to you. In this, the COAP is the web-based protocol application where we are using the DTLS in the COAP. So while protecting the message in the unicast system, we are using the DTLS security because DTLS only supports the unicast message, not the multicast. But COAP supports the multicast. So by this we are protecting by the cryptography algorithm where the encryption and decryption has been done. So COAP and the HTTP protocols are the same, where COAP utilizes the request and response is same as the HTTP, where the COAP improves the conventional analyzed, same with the HTTP, same as the COAP runs the UDP and TCP handshake protocols to avoid it. And you can also see that now while using the IoT, so they are the minimal header format of the COAP. So where it is also, you can say that it is efficient and requires less energy while communicating. So my problem statement is that I want to do communication in a multicast also, but the DTLS could not support the multicast communication. So DTLS cannot secure the multicast, but it only provides the security to unicast system. But I have used the COAP, Constraint Application Protocol. It is support the multicast, but without security. So I have used a less algorithm. LESS, less algorithm is being used for securing the unicast in the client server. The unicast communication is only secured by DTLS, not the multicast. COAP support the multicast. Here you can see the DTLS handshake protocol where the client and server is being communicated in a unicast form. My proposed work is I have proposed the key session has been generated from each of the nodes, or you can say from each sensor where the multicast communication is being done, and define the algorithm for the multicast communication. So the key distribution center is made for securing the communication. The KDC algorithm generates the session key for decryption as well for the encrypted message as well as the encryption for the decrypted message. So here you can see that where you can send the data or information from one to another device in a multicast communication. So we have been using the key distribution center. So here you can see that while they are communicating between multicast communication, so we use the COAP that provide DTLS, but DTLS do not support the multicast. But for supporting the security DTLS, we use the TLS/SSL protocol based security instead of DTLS. So it can be communicated in the multicast communication also. So while using the less algorithm, it only for unicast, but while using the TLS/SSL protocol based security is used for the multicast communication.